We're trying to solve a problem here.
Tomorrow's going to be very exciting.
We are so excited about the future.
I will build your roads.
We don't need roads.
Hello, and welcome to Solving for Tomorrow, Tales from the Tech Frontier, the show about tackling the biggest problems in the universe with technology. I'm your host, Brian Geisel, CEO of Geisel Software. We're here today with Tony Campbell, who is an awesome friend of mine, and I'm so glad that I was able to cajole him into doing an episode with us. And Tony and I meet regularly for lunch, and we have these amazing conversations about how to scale large corporations and why they suck and why no one can code very well and why we love Python, but it's stupid, and I don't know, whatever else. Tony's had a storied career. We worked together a million years ago at a company on a research project that was super interesting, super high pressure, quick deadlines, awesome stuff. It was a lot of fun. And then we both kind of went different ways. I ended up starting a company, and Tony went off and became a muckety-muck.
Yeah.
And has worked at Google, Microsoft, HubSpot, among others. And so I thought we have these super cool conversations about life, the universe, and everything, and coding and robots. And I thought we'd just have one of those and share it with you, the audience. How's that? Tony, thanks for coming.
Thanks for having me. I appreciate it. I hope I can live up to that introduction.
Is your arm okay after all the twisting?
I didn't fight. Come on, I didn't fight. I may have not been outgoing with my schedule as much, but no, I'm glad to be here. I listened to the show, and I hope I can live up to the hype.
Yeah. Well, okay. So let me continue. The hype is one last thing about Tony is if Tony produced content or chose to do conference speaking or whatever, everyone would know his name. He's one of these people who's influencing the industry and the culture in the industry in lots of ways. So the one last thing that I will add as an addendum to my introduction of Tony is that if Tony chose to publish and to speak at conferences and stuff, you would know his name. He's been influencing the industry in all kinds of ways, but Tony's maybe a little introverted, and I'd like to get him out a little more because just got a amazing depth of information, and I hope we can get a little bit of a dip into that depth today in our conversation. So we'll dive in from there.
Sounds great. I'm at your disposal.
So I'm thinking about a bunch of different things, and I hope for the audience we can jump into some things that are highly technical and why this thing that we do as developers is terrible.
Sure.
But also we'll try to give some explanations so that if you're not a developer, you're not highly technical, you'll at least get a sense of how the thing works or why we're doing things a certain way or why we're trying to solve problems in a particular way. And I think one of the things we talk about is the future and where the future is going from the different perspectives that we see. Let's jump into that in a little bit, but let's first start about, why don't we start with Connectar?
Okay. That was a part of a line of projects to get Telepresence going. It wasn't the first. It wasn't at that particular company. It wasn't the most advanced. It was after mobility in the home. The next challenge was manipulation or presence and stuff. And so that project was an exploration of how do we add something new to the mobile platform or the consumer robotics space. And manipulation was years, decades away at the time. This was, 17 years ago, something like that.
Yep.
And
you're talking about robotic manipulation.
Manipulation. Sorry. Yeah. it was decades away, presumably, for cost effective, at least in the home.
Yeah.
We're seeing a lot of buzz around that, but our compute budgets were much smaller back then, and so presence was another functionality or affordance that we could use to bring value to the consumer home. It was an easier problem to tackle than manipulation, telepresence and the world now with the prevalence of video communication and stuff. That was something that we were trying to explore. We had interesting problems. How do you gesture when you're remote? Things like that, because it really added to the experience and the sensation that you were somewhere else.
What do you mean by how do you gesture?
That thing over there, like what I just did, I was referring to that box over there. But when you have to describe it in words and stuff, it takes you out of that magical experience of being somewhere else in terms of telepresence. And so, could we have done it with a pointer or an arrow on the top of the robot that just said that thing or this card? One example was, I want to play cards with my kids. And so we would put it out in front of you, and like, I need play Go Fish or something, and you wanted to manipulate this card. We couldn't manipulate it, but we might indicate to the person on the other side, like, hey, could you pick up that card? And that was relative and requires a gesture, requires that emoting.
But it was sort of a 1978 Camaro red
yes, I remember that.
Toilet seat shaped sort of robot based on iRobot's Roomba platform. So low to the ground, circular robot that we're talking about. That was the telepresence. So imagine this donut trying to point at things. It can spin a lot, but it doesn't really show you where the thing is that you're supposed to be looking at, or
what the other person on the other side of that connection is looking at. Because you don't get eye contact. There was no sort of emotive capability on that thing. And it was an early design of some of the things we were trying to experiment. It was small enough that you could put it on a tabletop, for example, and play a card game or do something like that. But in a lot of ways, it was still early in sort of that products category, like a lot of the unreleased products from then.
Yeah. And we were just talking about it a minute ago, funny enough, because we have a meeting owl in our conference room. And I don't know for sure that the two founders of Meeting Owl worked with us while we were there.
Yeah.
And what we found while we didn't find a lot of uses for this robot. So as a tech company, this was one of the interesting things is the company started with the technology and then went looking for a market for it. And I think that was part of Colin Angle's, you would know this better than me, but I think he kind of had this philosophy that telepresence is going to be an important thing in the future. So let's figure out how to build telepresence, and there will just be a market need when we get there.
Yeah, I mean, the early solutions would lead to practical usage, like something that early in its sort of development as a product category. You're not going to have the end solution. Like, we didn't know about gestures, we didn't know about emoting. We had papers that we had read and sort of done the research on it, but those interactions would unlock us. I didn't realize that pointing was important for people for that sense of immersion, or the lack of eye contact from the outside the robot. You're staring at this donut, you call it, this donut, and like, that's not very exciting or compelling a feature set. You need to iterate, fail a few times, and sort of understand what combination of those things leads to sort of a compelling consumer experience. And so I mean, it had great ups and downs. We did struggle at times to find a compelling use case, but it was also an untapped category at the time. We're still trying to feel it out, and so the first few iterations were going to be a challenge. No matter, even if we got it right the first time, like we would have second guessed ourselves a ton.
So here was one thing that I thought was interesting is one of us got sick one day.
Mhm.
I don't remember if it was me or somebody else. I think
I
everything was
remember
me.
why.
You remember why we got sick?
Yeah, because the glue from those paper cups that we would drink the Arizona iced tea out of.
Yeah, we would alternate which one of us brought the gallon of Arizona iced tea that day. And then all of a sudden, our throats were closing shut and we couldn't figure out why. It's because we were using the hot coffee cups and the glue was leaking into our throats. But one of us didn't come into the office sick.
Mm-hmm.
And so the glue may have led us to what was we figured out if we put the connector on the table, it had cliff sensors. So the Roomba sweeping your or vacuuming your floor, it does both, wouldn't run over stairs and tumble down the stairs. It was really good at that. So if you put it on a table, it wouldn't run off the end of the table. So it turned out to be a really good conference app.
Yeah.
Where we could, as developers, we're using it to like, oh, shoot, I can sit in the meeting and I can spin it to turn and face Tony. And then a couple of years later, there's the meeting owl, which uses a 360-degree camera. And I don't actually know if it was just a direct thought or a side thought that maybe Mark and Max kind of got that they went and started the meeting owl. But I was like, that was the only thing to me that like hit me as a consumer. Like, oh, this is really useful.
Yeah. That was actually one of the interaction models early on, before we had the prototypes and the robots itself, was the portability of it and being able to, we had this use case of a father or parent away or sick and wanting to visit in with their kids, and having something that the kid could pick up and lug to their room to show them this thing that they built or whatever. And so it would be like dad in a box almost, or parent in a box kind of thing, where they would bring the robot. That was one of the earlier advantages of it. I don't know if it was the limitations of our tooling that required it to be in a certain form factor, but that was one of those features that we thought would be compelling. An important thing I found in my career and understanding why engineering, why mechanical engineering, why not chemistry, why not physics, kind of stuff, was the maturity of the field at the time. And so, like, if you look at chemistry, it's a different point in the maturity, the discoveries that can be made versus physics. And I knew myself well enough and what my strengths were, or had an inkling at that time of what my strengths and weaknesses were. And I started to gain more understanding of where consumer robotics and robotics in general was. And I wasn't the right guy for the next 20 or so years. I felt that it was a different, the industry was at a different phase from the kind of things that I like to do. I'm much more of a tinkerer and experimenter. The compute budgets, the maturity of like.
Do you think it was still too much in the R&D phase at that point?
A little bit, and a little bit of the market defining phase. What does, we
didn't know what to do with it.
We didn't know what to do with it. We had a lot of this.
Robotics was a vertical.
Yeah.
It's not anymore.
It's not. About 2 decades, I was right. But for me, anyway.
Yeah.
But we had this, like, we wanted to make Rosie from the Jetsons, and everybody was like, this is the future that I'm buying into. But there were enough technical hurdles between like practical in the home kind of robotics and that future, that there was going to be some time of grinding it out, basically. And I wanted to get more iterations, more experiments done in my career. And so I instead shifted to something else that was becoming hot and exciting, this thing called the internet kind of stuff. And I thought that was going to become a more prevalent part of our lives. This was, early 2000s, part of our lives. And I saw a lot of advantages of how to leverage it in sort of the network enabled robotics to offset some of the challenges with local compute and battery capacity and stuff. And so wanted to understand how the internet worked. And so shifted a little bit more to that so that I could bring it back when the opportunities in the robotics vertical, as you call it, were there and could benefit from somebody like me, that I could get excited. it's not excited. Excited's the wrong word. Activated and leveraging my strengths to build a useful career, to make the world better, and have a positive impact. And I could see, just like I liked physics better than chemistry because of the relative maturities of the worlds, what are the fields, what are sort of axioms for each of them, and what are the assumptions of each. I could sense that it was too early for me to be excited in the ways that I wanted to be excited in my career. So I went and looked at something else temporarily. I bounced back and forth between different fields all through my career, just following the hard problems. But it just happened that there was enough depth in the internet thing to really sort of figure that out.
Which is funny because your college was in mechanical engineering, right?
Yeah. I did that because I didn't feel that I loved physics was my thing. I loved.
But then you went to software. You're one of the best software engineers I know.
Thank you.
How do you go from mechanical engineer to really good software engineer?
My first job, actually. I mentioned this before about cycle times, iterations, learning, and I'm sort of a self-learner. And the best way to learn is to make something and mess it up and fail or succeed and go through this process of iteration. I'm not, my particular way of thinking isn't very textbook linear for stuff. I jump around a little bit more, and I like to be a little bit more hands-on. Mechanical engineering was too slow. It would take us 3 years to build a product, to build a bracket in my small component. I could release software back then very rapidly and learn and hone my craft of building, applying science to the real world problems a lot faster, and get that feedback and that dopamine hit of shipping something. And the cycle times were too long between. Nothing against mechanical, nothing against that kind of stuff, but I was more addicted to the hits of like launching something and seeing the effect of it and going, oh, that wasn't quite right. Let's gesture. Let's add something and learning from that. I was in a rush a little bit to leave a mark on the world, so I wanted to make sure I had enough cycles or iterations in my career to do that. And I found software to be a little bit more convenient way to rapidly grow in maturity as an engineer, not necessarily software or mechanical. And I was always sort of a hybrid anyway. It was an arbitrary decision back in college anyway.
Yeah. So, okay, I want to jump us around a little bit. So you went not long after we worked together, you went to Google. And then,
I didn't actually go to Google. I went to another place in Cambridge, and we were acquired by Google. It was sort of
we'll count it.
Yeah, okay, we'll count it. But it wasn't. I didn't like
direct. Yeah, sure, that's fair. But you ended up working at Google.
Yes.
But then you went on for the mechanical engineer. You went to write software to make software.
Yes. Yeah. Platform stuff, reliability stuff. Yeah.
You went to GitHub.
I went to GitHub. Yep.
And so I'm going to dive us down a rat hole because we've been talking about some things in Git recently.
Yes.
And we had some challenges on our team where we got stuck in pull requests.
Yeah.
So let me try to do this quick for folks who aren't software developers. One of the things that we do as software engineers is we hate to make progress and then lose it. And you're constantly iterating, you're constantly changing things all the time. And so what we do is we use these things like Git is one of the tools that we use where we have a common repository. And we'll be working on the same code base, and Tony might make some changes and I'll make some changes into this common repository. And we now have sophisticated tools where Tony's change can go in and my change can go into the repository. And maybe I'll have you pick it up there on what a pull request is then.
Sure. I mean, you can also, something that might be more familiar is like a Google Doc where you have multiple people typing at the same time. This is a similar, more static way, but it sort of underpins how collaborative software is written. And as you can imagine, you might both be editing the same section of the document. You might be deleting stuff that somebody else wrote. It's a collaborative, shared exercise. But in the case of Git and other software development, it's in writing software that needs to function on some form of computer or whatever. Although people use Git for all sorts of things, not necessarily just code. A pull request
Sounds like somebody who worked at GitHub.
I did. A pull request is a way to stage these changes. And so think of a set of source code to your software application, or a shared, that shared saved state of source code. It's rude or difficult to collaborate with you and me on this shared code base if we don't communicate as people as well.
Yeah.
And so well, that code I wrote yesterday is gone. What happened? It turns out it was junk, and you rewrote it or wrote it differently, or you had a better understanding of it. And so the pull request is a way for us to batch up changes so that our shared repository, our shared view, because you might have your own copy of it, I have my own copy of it, and we sync up every now and then. It's a way for you to share that change with me, for me to review it, to understand it, to ask questions, maybe to suggest changes, for us to, it's part of the collaborative.
It's a form of communication.
It's a form of communication. It goes to not just Git, but other source control systems that predate that, and it's not a solely for Git, but it's a way for you and
SVN,
I to discuss
CVS, RCS, yeah.
Like all the source control systems, where it's basically we are editing text files together, but we're not in the same room. Perhaps we're not in the same time zone even, and we need to. What are you doing? There's great videos of coding jams where they don't allow people to talk to each other, and they just give them a problem and say, you three go create software to do this. And it's fun to watch because they can't talk to each other, so they don't understand the shared state. Are
you allowed to put comments in when you push
No. It's like blind coding, and it turns out differently than they all expect.
Well, C is self-documenting, so if you do it in C, that make that easier.
But anyway, a pull request is a way to bundle a set of changes and offer it for peer review, almost like you would. We're acting as editors of each other's writing, and it lets us write with the same voice, the same style, the same mental models in it. It's an educational thing where you may be more familiar with the code base than I am, and I'm making a bunch of assumptions that you could then say, hey, you know what, we already have a library, we already have code that does this, you don't need to do this, or in our project, we tend to do it this way as opposed to the way that you're suggesting here. Take a look at this, or I didn't see this, that's very interesting. I didn't realize that we could do this in this code base. This is educational for me. In our relationship as collaborative editors, we have this shared responsibility of maintenance of this code. We don't own the code, really. We're maintaining it, storing it. But for either of us to be effective at it, we need to understand basically how it works. We might be experts in some sections, but this also lets you and I, outside the code base, outside of comments, to talk about design decisions, why I'm making this change. Why I think it's important that we do it this way or that way. Not quite design docs, but like, hey, look at this change I'm about to do. It's going to be not backwards compatible, but I think it's important because the following things, and this is what I'm thinking. What do you think? And then that becomes a separate conversation. You can do it on GitHub or whatever, your mailing list, or your kernel mailing list, or whatever. Like, there are different examples and different tones and cultures for collaborating. And a pull request is one way to both indoctrinate people, to train them up, to get them to learn the voice of that code base, as well as traceability. Big companies, you probably need more than one person to look at any change, for malicious actors or mistakes or culpability. You would want to have like two sets of eyes on every change. And so I would issue a pull request, but wouldn't be able to take those changes and apply it to our shared repository without you saying yes.
Without someone else approving
it.
So I want to double click in a second on a thing you said about like the shared mental model.
Yeah, hugely important.
Yeah,
Huge.
and I
It's
think
overlooked all the time.
there's an evolution there. But the one that I want to just step into quickly, because we had a discussion about it, I thought it was really a tactical, useful thing, was we had this issue. Do you remember the old, I think it was a Budweiser commercial where they're like, tastes great, less filling, tastes great,
Less filling.
tastes great.
Yeah.
So we had an issue on our dev team where we're like, you should use a for loop, and you used a while loop.
Mhm.
And then the other developer was like, no, this should definitely be a while loop.
Mhm.
No, this should be a for loop, while loop, for loop, while loop.
Yep.
And you had this great, like, listen, this is what a pull request is supposed to be for,
Mhm.
that just made that, how do I manage this repository with the developers?
Yeah.
It just melted away. The problem melted away.
Was that the turnaround, or was it the one letter grade?
Yeah.
The point of a pull request is not for you to be a gatekeeper of my changes. You might be the tech lead of the project and responsible for its overall quality in a business sense, or you may be the primary maintainer, but it is not, it's less healthy when you are trying to, I need to code exactly like you. Instead, where pull requests are very helpful is like, you're helping me get better at the craft of writing software. And so the goal of a pull request would be in this situation, help me get my code one grade better. It's not going to be perfect. Code is a living thing. That's one of the benefits of writing software, is that it evolves over time. And you get into these rat holes of tastes great, less filling, tastes great. I remember suggesting limit the turnarounds to 3 back and forths, because if you keep telling me my for loop is wrong and I should use the while loop or whatever, do it 3 times and I'm going to feel pretty crappy. I'm not going to want to work with you,
Right.
like I'm going to be gun shy the next time with my changes. I'm going to second guess myself. The point is not for me to write code that you would have written. It's to mentor me so that I can write better with the voice, or for us to discuss that voice and like, what is the proper, the mental model, let's ban all for loops. Everything's a while loop. Like it could be that might be part of the
right. Sure. Yeah.
But what happens is, especially with the responsibilities of your peers in a shared repository, you get this like gatekeeper thing going on, as opposed to a gardener.
I like that.
You're not a gatekeeper. It's healthier to think like, you're shared collaborators on a project. You're trying to make everybody around you better. You're trying to code in one coherent voice is better. It's easier to follow. It's easier to read. Yeah. So I would say like the non-functional requirements of that makes it a better code base. And so that means you and I, when I collaborate with you on a project, I know I have to use while loops. That might be something that's not an absolute in an industry or something at another place. Or
I have a friend who has a religious obligation to write while loops.
They may do it. The thing for me is, when I collaborate, especially from an open source perspective, when I collaborate in your open source project or your repo, can anybody tell that I wrote it, or that it's just the voice of that code base?
Right.
And so pull requests really help with this. And like the back and forth, like you're not going to win. There's a lot of stuff on like how to write effective pull requests. One of them is like 2, 3 back and forths to do it. If it's still not there, break it up into smaller pieces that are unobjectionable, so I can make progress this week, or I can get some bit of functionality. Have an offline conversation, discuss it with them, or defer to the author. Like, I put a lot of energy, and you trust me as an engineer that I'm doing it for a certain reason. This is a way for you to extend trust and vulnerability. It doesn't have to be exactly the way you wrote it, because you know what? I'm not a clone of you as a software. You don't want me to be a clone of you as a software engineer. And so you let a little bit of that, I think a for loop here is good. It's your perspective. I don't think so, blah, blah, talk it through. And then like, okay, we need to get this code in. The point is not to like gatekeep this pull request or these changes. The point is for us to move this code base forward, or to add some feature or something that the people want to use out of it. And okay, get it in. Also, and then if you really are sticky about it, make another pull request and change it to a while loop, and have that as a separate conversation or a separate issue that can either be like, that doesn't make any sense. You're just sort of nesting in the familiar constructs that you're used to. You get to learn like all the different ways that I use or abuse for loops in my code.
Right.
Like you get to like pick up through osmosis. We both get better for
Right.
that. And
There was a great use case of this in a recent project. I jumped in to do some
Mhm.
code, and I've done Python for a long time, but not recently.
Yeah.
And so the team started using type hints.
Mm-hmm.
Are you okay?
Yeah. Oh yeah. I remember sending you a snarky comment on that. Yeah.
There is a Pythonista thing about you shouldn't have to worry about what the type is in Python. You shouldn't ask what the type is. You shouldn't need to know. But in this code base, to your point earlier, right? The code base was we're starting to use some type hint stuff.
Mhm.
And the way that I inserted the type hints, because that's new to me, was wrong. And so in the PR, somebody said, hey, type hints don't go here. They don't go in the init.
Yeah.
They go on the class itself.
Yeah.
And I was like,
Thanks.
I learned.
Yep.
It wasn't just like change the code, you're stupid.
Yep.
I learned how this new feature that I haven't used before works and how to do it the right way without having to go study on it for 8 weeks. Like one of the other developers was like, hey, in your code, because I can touch and feel that, so I can learn faster from that. Here's how you do it there. I thought that was a great comment on a PR.
Yeah, I think software, in at least professional people who code to pay the bills kind of stuff, it's a very still very much an apprenticeship model of learning.
Yeah.
Because you have to learn both the code base, but you learn on the job coding from people who are more experienced than you. There isn't a formal curriculum. Writing software professionally is very different from school or from open source. The constraints, the non-functional requirements on the code base are very, very different.
Mm-hmm.
And we don't have a way to effectively formally train somebody. So it takes an apprenticeship model. You have a lead who's more experienced in the code base or in the language or the technology, that gives you these little hints and nudges from it. But they need to see your code. They need to review your code in order to do this. And it works both ways because we're always learning. But it's an important part of this apprenticeship style that the software industry is in. There's a lot of like, going to learn it on myself, going to figure it out kind of stuff. But in a group, when you're on a team, you have a shared code base, you're all at different points in your career or expertise with this technology. You're all learning. Ideally, you want to structure this team so everybody is learning something new and mentoring each other on the code base.
Let me ask you on that.
Yeah.
So you've been at Google, at HubSpot, at Microsoft. I don't know, they need to know what percentage it is, but how often are they hiring people with a degree in computer science versus they don't, or it's in something totally different, or they don't have a degree at all? Like how important is that at those companies? Not even those specific, right? But
I don't think it's super relevant. In these larger companies, there's a pipeline that you go through that as a hiring manager, I wouldn't even have, like, they've already been vetted through something. So I don't have the widest pool of candidates to evaluate. These people have already gone through a couple of sections of the funnel. In smaller companies, maybe GitHub before it was Microsoft, we would have a little bit more flexibility and be able to see somebody more holistically based than sort of their education or the companies that they've worked at before. Open source is a great way to perform, to do that. I've looked at people's repos when considering hiring them. It's like, I just want to see a sample of your work. You get good at reading other people's code and understanding, is this person a jerk? You can tell from their voice in a lot of cases. You can see a lot in someone's work. I would weigh, and there have been people I've brought on that didn't have degrees, but had an open source presence or did that, and it was a big win for us to convince them to work with us because we got to learn from them. They clearly could do the job, but they didn't come from the conventional 4-year degree boot camp.
Right.
Blah, blah, blah.
Right.
Me personally, I don't care.
How many times have you gotten a GitHub repo that they put on their resume that you thought, don't show me that? Just lie. Tell me you don't have one.
Never.
Really?
Never.
Come on.
A lot of people, not enough people put that as part of their thing. And like, don't show me
Oh,
your
we
user
get-
GitHub
we get
username.
so
Give me
many.
give me a project that's relevant.
Yes, right.
Give me one of your repos that you think is like, this is where I flourished with for loops. This is why I'm so excited about that. And like, show me the interest in that, and
Yeah.
like, point out the code, point out like
That's
a
good.
PR that you found that was interesting. To me, that's signal boosting to the important stuff.
Yeah.
I can read that and interpret that without knowing the problem that you're trying to solve. I can see if that fits in well with one of the existing teams that are looking for somebody to join them. Like, don't send me your slash username
Yeah.
kind of stuff. 'Cause
Sometimes, so many times I get that, and you have 5 repos in there of all broken code from college.
Yeah.
That doesn't
no
help.
contributions in the last 2 years.
Yeah.
No, there's other ways. Show me a PR where you made a suggestion to an open source project and it got shot down, and how you handled that. And like, that's just as relevant, because that happens in business all the time. Like, let's not do it this way. Or show me a pet project, and not the whole pet project. That's great. Show me how you documented it. If that's what you're trying to emphasize, signal boost the important things of like working as a peer and a fellow stakeholder in a repo. Don't
show me how you added a period or a semicolon.
Show me as how you convinced that other person to use for loops instead of while loops.
Boy, yeah.
And like, convey that, and like, you were polite,
because it's not just how good your code is,
right?
It's this communication and working with others to get a thing accomplished.
And jarring as you go to your section of the code versus my section of the code.
Yep.
I worked in code bases where we have worked in code bases together,
where
it's very obvious who wrote that bit of code. And it was jarring. You could jump.
Do you remember the 2,400 line switch statement?
Yeah. Wonderful engineer, brilliant engineer. I mean, I've been guilty of some really bad code, but like, being able to write code is, if you don't write the bad stuff, you're just reinforcing your own self-image that I'm a superstar or whatever. It's like, no, if you're not failing, if you're not writing something that like later you go, ooh, that's kind of gross, then you haven't grown anything since you wrote that code. And so like, you need to see that trail of missteps, things I wouldn't do today. And like, I'm sure you have a bunch of coding examples like, oh, I would never do it that way.
They're in repos.
Yeah.
You can go read them. In fact, that one, it's a really good point. That one that I'm mentioning was specifically an experiment.
Yeah.
It was trying to do yields and stuff in C code, right?
Yeah.
That was okay. Let me shift this, because I wish we could do this for another hour and a half. But I want to ask a couple of last things. Is like, we're talking about the software development process. I think one of the things we used to do is, even really big projects, it was best if it was written by one person, because they had the whole architecture in their head.
Yep.
It meant the number of bugs you wrote was so much less. Right? You
great career protection. It was,
and there was that as well. But this shared mental state that you mentioned on, like, as you're doing PRs and stuff, and I don't know if that's it, but what's the next step of evolution of software? And we didn't get into the SRE side of things, where like part of it is keeping the stuff up and running, and
the code you write with that in mind is very different than you would normally, or that most people are trained with. Distributed systems are very different from the kind of classical education software that we all write. And that's one of the challenges of being in that field, is that it's non-intuitive when you're thinking about all the different parts that can fail.
Can you tell people what an SRE is for 10
Site
seconds?
Reliability engineer. They keep the internet up.
There you go.
That's probably the best way. Everybody wants to write reliable software. That's an aspiration that everybody writes. Turns out it's non-trivial. It's a hard problem. It's non-obvious how to do this, how the software above you or below you can fail. And so there's SREs are something that Google came up with and has sort of proliferated throughout sort of the cloud-centric software industry as a way to increase the reliability of services that run on the internet. So
let me shift this to one final. As we talk about solving for tomorrow on the podcast.
Yeah.
What, as you looked 20 years ago, you went, the robotics industry is going to take too long to get where it's interesting to me.
Mm-hmm.
Where do we sit today? Could be robotics software. There's a comma, robotics or software, right? What do you see 20 years from now? Or what do you, I guess, maybe if I ask it this way, if you had a magic wand and you could fix one thing, what's the thing that you would touch?
How magic is this wand? I've heard you talk about breaking the laws of physics.
Yeah.
I know, like, political regulation landscapes. That's kind of a cop-out answer. I mean, I think power generation is an important one. I would love to, if I had magic, room temperature superconductors, that would be something that would transform power transmission. And like, we're consuming more and more power, right? And this whole centralized power creation facilities, these long transmission lines that consume it, magnetic levitation, like there's a whole bunch of stuff that in a video games tech tree, that would be a technology that unlocks a whole bunch of new options for you to place on the map. That would be one. That would be one. I think, you were talking a little bit about AI and stuff. I think next decade, maybe, and I'm saying this, so it's gonna come back and haunt me. Right? I feel in my experiments and when I play around, I've got a new tool. I've got a new jig in my workshop.
Yep.
I don't know. I got no instruction manual. I don't know how it's supposed to be used or whatever,
right.
But it's changing the way that I build stuff. And I may be using it upside down or not in the way that's really effective. But I think in the software development flow, we need to figure out and figure out what to do with this weird shaped jig to build stuff, because we know that it can do stuff.
It's a really useful tool, but what's it for?
But I haven't figured it out yet. I'm trying to use a hammer as a screwdriver with the nail remover side. And like this doesn't feel right. It's awkward. The code quality, the resulting code quality isn't there. It's but at other times it has such broad context. I can ask it about my code base and suddenly get an answer that I would have taken me 8 hours to figure out.
Right.
And so I think the next phase is, or the future thing, is figuring out what to do with this new tool that just showed up in our code base. And then the real human ramification parts of that is like, it eats out a lot of the bottom of the software industry. That seems to, like, junior devs, that it makes it harder for them. How do we need to shift to that other tool, how to use it, and then how do we get it so that we can have a sustainable field by letting these newcomers to our field hit escape velocity and break through what the tool can do to be on the other side. So those two things are, I think are the challenges that I try to figure out, how to do that. And then how do we make sure that there isn't a 20-year gap in software engineers because, the industry or the business tries to commoditize basic knowledge around that. And then it turns to us, like, as members of this field, like, how do we, reach through that, being presumably on the other side? How do we get that escape velocity again for other people so that they can become experts in something, so that they're not competing against the AWS cost to run the LLM for you? And so those are the two things that I would sort of I fixate on a little bit in terms of software development for it. And a lot of this tool is very versatile. It's going to change. Like, the way we use pull requests today might change. It may be very different. The way we talk about the software outside of the software may change. So there's a lot there. But I would stick to those two things. I would love it also. I would love to delegate a little bit, like, if more of that wand shaking, a little bit of that extra fairy dust on there. I don't like the chat interface. We're running out of time. I would like a stateful agent on the other side suggesting things to me. And so a long-running agent that talks and that I can talk about the code base and suggest changes. Not, how do I do this loop? What's the protocol for here? Implement the socket, implement the network programming for this part of the code base. Instead of doing that, it'd be like, where should we optimize? Where do you see is the worrisome parts or the bug-ridden places of this code base? I think those kinds of questions, again, that feels like a better use of that tool rather
Yeah.
than generate convert all my for loops
Yeah.
to while loops.
Yeah. I think it's going to be fascinating when we solve that piece of it, as we get better at that.
Thanks a lot for watching Solving for Tomorrow. Like, subscribe, connect on all the social medias if you like more of this. More to come.
Hey, you're not Tony.
I'm not. I kind of still Tony C.
It was nice to have Tony in person, I thought.
I feel like, of course, the conversation, you guys talk all the time. I'm aware of this because of your Wednesday meetings, but I feel like having your friend here, because you guys have been friends for a while now.
Yeah.
That probably was a change of conversation, right?
Yeah, it was nice both to know a little bit about what Tony can dive into, but also he thinks such deep thoughts about so many great things that it's always interesting. And that was one of the reasons I wanted to have him on the show, is like with his amazing talks at lunch about all sorts of things that we all learn so much from.
Right.
And I thought that would be cool to kind of share with the audience and let other people learn from some of those things and from some of the experience Tony has.
Before I give my takeaways, I want to know what your takeaways were. Like, I know you mentioned you guys were talking a little bit about the pull requests, and I know you mentioned that's a problem you were having. So I kind of want to know because it feels like when he came here, you actually got something out of it too. Like, not just a great conversation, but you had a problem solved. So that's a feeling I'm getting. You can correct me if I'm wrong.
Yeah, no, and we had Tony actually stick around and do a tech talk here after or before, however the timing worked out, which was really great. And we talked about, I don't know, a bunch of Python stuff and a bunch of Git stuff, and I think the things around those things, if we don't know how to use Git in the software world, we can use ChatGPT or Gemini or Google to just answer some of that stuff. And how do I use this in Git or whatever? Like, I don't necessarily need to ask another developer that, but sometimes a way in which people use the tools.
Yeah.
And sometimes you get these things where you're like, oh, I never thought about solving the problem that way, or I never thought about using that tool to solve that particular problem, because isn't it for this other problem?
Yeah. You know what's so crazy? And maybe because I'm not in the software development world like that. I mean, I'm kind of in that world, but I'm not a software engineer, so I wouldn't really know what goes on. But I really do feel like this was kind of like in any job, they give you pro tips on what to do and not to do. And that's what I got out of this. Like, oh, as a software engineer, you're familiar with your tools already.
Right.
But like, here's a little bit of an advice from somebody who's been in the field for a while, kind of like a mentor who's like guiding and training you. And I felt like that's how the conversation felt like. And I truly enjoyed it a lot because I was like, oh, that's really cool. And maybe this is a stereotype of mine or this is my own assumption, but I always feel like software development is a field that people in there are smart enough. They have a lot of interest and they know what they're doing. That's like the number one thing. Like, mostly with doctors, usually sometimes a parent tells you to do it or and you get into it. A lot of software development stories start from I just started picking something up, picking it apart, and then I decided to be a software engineer. So it feels like a field where you actually have to have interest. And so there's a lot of people who already know what they're doing. So I don't really see it as a field where you can have a mentor that corrects you on what you're doing. So it was really nice to see that side that Tony brought up, that it is still a field where you can still take something from somebody who's been in it for a while, right? Like you can take something from a veteran. So that's what I got out of it.
And in a weird like tangent, I was thinking about this the other day, is how often coders who are really good musicians are really good coders. I can't think of a time where I met someone who is a coder, you know, who writes software for a living, who's a very good musician, but a crappy developer. Can't think of that case. And one of the reasons I think is how similar they are. One thing is in music, and this is its whole other public service announcement, is in music, people who don't play music think it's talent.
Yeah.
And people who play music know that it's effort.
Yeah.
It's just how many hours have you spent working on that thing?
Right.
And there's only so many people in this world that have this additional talent piece that is yo-yo ma. It distinguishes it from just the work. But how far you can get with effort is so far, even if you don't really have great talent in it. And so people who are very good at music, talented or not, have put a ton of time and effort into it. And you have to do it independently. Like, you have to practice 40 hours a week or 60 hours a week or whatever. There's no music teacher that sits with you 60 hours a week.
Yeah.
You have to practice on your own.
Do.
And that's the same thing as if you just go to school for software development, the best you're going to be is a mediocre software developer.
Right.
You have to do it outside of that, just like you do music. And so I was thinking about that corollary, but it's similar in the way you're talking about the mentorship, because if you watch great musicians comment on one another's music or mentor each other, somebody plays a piece of music and it's beautiful. And then somebody who's that next level.
Yeah. Can see what's going on, can help you tweak it a little bit,
Yeah.
or give you a key where you didn't think so. I don't know if people know this, but I kind of want to share the story. There was a story of Kanye West saying that he's a good producer. Everybody knows that. But he had to go to Timberland, like a veteran producer, because he was trying to produce this song and it just wasn't working. And he had to go to the guy that knows a lot more about how to like do the beats and do everything. And whilst he's good at his craft, he was able to like tweak it in a way where he would have never thought about. So what you're saying, like, that's the first thing I'm thinking about. Like, that is true. There's a lot of veteran like musicians that say, "Oh, I couldn't play that note, or I couldn't play this key," and somebody said, "Why don't you play it like this?" You know?
And they can play the note,
Right.
but it's like, I had a friend who's a great musician, and he said his mentor asked him one day, "Why did you play that note?" And he was like, "What do you mean, why?" I don't know. Well, figure out why you played that note. Or there's this great clip of Benjamin Zander, who's like the conductor of the Boston Symphony Orchestra, I believe, maybe emeritus now. But there's this great clip where he's helping this amazing 15-year-old cellist who's playing one of the Bach pieces. And he says, "Okay, play that again." And he plays it great. It's great. It's not moving, but it's great. All the notes are perfect.
It's not moving.
No, you didn't feel it emotionally.
Right.
But he played all the correct notes.
Yeah.
And Benjamin has him go, "Play it again, like this, like this." And at one point he says to him, "Why don't you play that D on one buttocks?"
What?
And you can see him kind of look at him like, "What?" And he goes, "As you play the note, don't just play the note, but play it and lean into it like this." Harry, when he does it, it sounds better. You are emotionally moved by the note because all of a sudden he, the musician, is in that note and he's feeling the note. And as funny as that is, that he says, "Try it on one buttocks." But as
I feel the public service announcement, he just said this so he can say that word, by the way. So just a PSA for people listening.
It's just a great example,
God.
Harriet.
I
I
can't
looked in my
believe
bag
this.
of great examples,
No,
and this
it
was
was not.
one of the best.
It was not. I'm sorry. But we'll take
It
it.
didn't have two buttocks.
We'll take it.
It was just the one.
But yeah, speaking.
But it sounds different. And just
Right.
by just moving his position as he played that note, he put more in emotion and you felt more emotion in the note. And so that's the kind of thing, like we were talking about, like, how do I do a git commit? Well, dude, go look it up on Google. Don't ask me that. That's your fault. That's an easy thing to find out the answer to. But like one of the suggestions Tony was talking about is when you do a code review, do it. Your goal is to help improve the code one letter grade. And I thought that was such an insightful way to think about what you're doing with a code review. We all know how to do a code review, but How do we do it well?
Mm-hmm.
And what do we really do that elevates the code of all of us? Because if we do it mechanical,
Mm-hmm.
like the guy played that D note and we just
Right.
do a code review because we're supposed to do a code review and I'm supposed to criticize you now,
Right.
so
It
I will
loses
criticize you.
the purpose.
And it becomes negative value.
Mm-hmm.
But if instead we can go, oh, my job is to look through
Mm-hmm.
this code and help improve it one letter grade. Now I'm in a different mental state when I do that. And I'm going, how can I help you make your code better? And you know what? If you don't like my suggestion, then you don't use it.
Mm.
But if you do and you go, and this happens to me all the time, somebody says, oh, well, why don't you use this library for that? Or why did you do it this way? You could just do this. And I'm like, I never thought of that. Or I had no idea that library existed. Yep, I'll go change that. I'll go use that. That sounds way easier than the way I did it. And so then we all get better that way.
Hey, I just want to let you know you commit broke my code.
Oh my God. That was perfect. I did not expect this.
I think we should do it again. We have to unbreak Harriet. No, and those are things that in like my code, like developers have said, hey, in a code review, there's a library for this, right? Or why don't you consider doing it this way? And I'm like, oh yeah, that is a shorter way to do it I hadn't thought of. Or no, I didn't even know that library existed.
Yeah.
And so then all of a sudden I changed my code and my code is one letter grade better.
Right.
Which is exactly what Tony was talking about. And I
Yeah,
think
and you have to
makes it. Oh,
Hey, sorry for the interruption, but your last commit broke my code.
what?
Yeah.
What are you doing in here?
Sorry, you broke my code. I just need to.
I don't think I did.
I have proof. It's failing to run now.
Right now is when we have to talk about this. We're in the middle of shooting a podcast episode.
I mean, it's fine. You just cut it, fix it in post. You
I feel like the producers are tired of us.
We were kind of in a flow.
What's
I thought we
going
were in
on?
a flow.
We were in the flow, yeah.
you just cut it and fix it. It's fine.
Okay.
Can we do this later and get back to the podcast?
And that, ladies and gentlemen, is an example of a bad soft skill.
That was
Thank you,
perfect.
Jonathan.
You're welcome.
Thanks.
We'll use Jonathan to transition ourselves to soft skills in developers. That's all, folks.
Go ahead.
I love Jonathan. That was awesome. And a great segue into soft skills.
Yeah. I have an article here that our producer sent to us, and it talks about I had a question to you at first. I remember I asked you this maybe a couple days ago or whatever. But I was like, do engineers, when you're hiring engineers, I know you look for the hard skills, which are your
Can they code?
Yeah, can you code?
Yeah.
And then the soft skills, which I've actually never thought about that. I've never thought, what do you really look for in soft skills? So I do have what I believe, it says 5 soft skills every developer should have. This is
Okay,
from
let's
the
see.
IEE Computer Society.
Yeah, you read and I'll judge.
Yeah, I'll get, we can have the link there in case somebody wants to read it. But the first one is safe awareness, which I thought that was interesting. It's, so the description is it's essential for software developers because it helps them understand their emotions, behavior, and knowing your strength, being honest with your skills, and much more. So I don't know what safe awareness is. Have you heard of that?
I have no idea what that means.
I don't know what that means either. It's just an important skill to have, supposedly. Communicating well, managing emotions, recognizing your limit. That's what safe awareness means. Okay. He hasn't heard
I
of it.
don't know.
Okay, how about critical thinking and problem solving? Do you look for that?
That's huge. In fact, it's probably a hard skill.
Really?
Yeah, I mean,
I figure a lot of them are problem solvers. Don't you code to problem solve?
that's exactly right. Coding is solving problems. We just happen to use software to do it an awful lot.
Right. So
So that's
Shouldn't
the job. Problem
it's
solving
like
is the whole job.
yeah, shouldn't you have it in general?
Yeah,
Okay.
absolutely.
So
Absolutely.
it's still something you look
Yep,
for.
for
What
sure.
about open-mindedness? Open-mindedness. Oh.
In fact, it's something we test for in our interviews. Is you might give us the right answer. We might tell you we don't want that answer. We want it a different way. And you will see
Oh.
some people who cannot come up with another way to answer the question. And sometimes the way you came up with it, you're so sure is the best answer, is not the best answer because of context. Maybe it's the team is better in a different technology. So even though that's not the perfect technology for it, maybe we should solve it in this other technology anyway. So given context, that might not be the best answer. What else could we do? And some people will just get stuck in a rut and can't break
So
out of that. That's huge.
adaptability is
Yeah.
important.
Yep.
Okay.
Yep.
The next one they have is time management. This one I don't need to ask you because I 100% agree. This is the reason why I work here. He cannot manage his time. Maybe he can. I won't say you can't. He is cutting my checks, so he can manage his time. So I'm not gonna say anything.
Yeah, and I'll turn that one into a little bit a medium, hard, soft skill. I don't know.
Medium. Medium.
What's between hard and soft?
I'm sure it's medium.
A doughy skill. Something. Anyway, one of the things is like I don't know how much time management, but knowing how long something's going to take.
Yeah.
Really, really difficult for developers. It takes effort. It takes experience to understand how no one's ever done this before. So how long is it going to take? That's a really
So
difficult.
You're not talking about time management just to do your work. You're talking about being able to like assess if you have a project, how long that takes you to do it.
Yeah. Yeah. And I say it because the time management, I like this because it's interesting discussion points. The time management standpoint, I don't know. Some days I code 12 hours that day.
Right.
I didn't really need to manage my time. I just sit in front of my computer and work.
Right.
So in that sense, the time management in the way you manage time or me being CEO, I have to manage my time. That's important to a CEO. Right. Yeah, it's important to developers, but I think in a different way. Now, somebody's going to comment on this and have a great way that everyone needs to manage time as developers. But
true, but like that's so cool. That's so interesting. I think this is why I like being in this field so much. Not that everybody here is so different, but it's like you take the strict things in the world that everybody's supposed to be doing, and then you guys just flip it. I love that. I love the fact that time management means something else. It can mean something else here. Okay, I think the other one is communicate. The last one is communication. Actually, no. I have one more. Actually, I think that's interesting. But yes, the another one they have is communication.
Communication is unquestionably huge and really hard because as developers, we often that whole thing we're talking about music, we learn independently.
Yeah.
So the way we learned it was by ourselves, and now I have to work with you. What are you, crazy?
Yeah,
I do this by myself. So as you're building a big team, that communication, it's sort of built into us to not communicate.
Yeah.
And so that experience and that recognition that, hey, dude, you're going to have to communicate for this to work. That it's not only is it an important soft skill, it's probably the hardest one for developers to have.
Yeah. When I read the article, I remembered something you said once. You're like, I don't like when people touch my code. And I was like, oh, I guess he has problems with that too.
Yeah.
So that's like and I'm sure a lot of people don't like, and I can tell because the one time I did try my hands at coding, and I was like, oh, why are we changing that?
Yeah, right. It's very personal.
Yeah.
Again, kind of like writing music. Like if you write it's very personal. I had somebody one time, lovely, lovely man. And this is the kind of communication thing. I come into my office in the morning. I haven't even sat down yet. And he is bouncing outside my office, up and down. And this is what he says. I fixed your code. I fixed your code. I found a bug in your code. I fixed your code.
Yeah.
And I was like, such a sweet guy. And he didn't have the recognition that someone else might be hurt that there was a bug in their code. Right. And I knew that about him. And I was just in my head, I was like, if you were any other man, I would kill you where you stand. But he was so happy that he was able to fix the
Yeah.
bug. And that's great. I was happy for him. I was happy that he was happy. But that piece of like, that's good for him to learn to
Right.
communicate that somebody else might not be that excited about it, but also important on my side to go, hey, he doesn't get that yet, and
Mhm.
he's not being offensive,
Right.
right?
Do you think that man will hear this podcast and say, hmm, he could, why is he throwing shade at me?
Oh, I don't think he'd ever remember that was him. And if you
Okay.
do, I love you.
Okay, the last one we have is patience.
Yeah.
That's the conclusion of the soft skills engineer should have, having patience. And I was like, what does that mean? Does that mean you guys are angry or something? Like, what is going on?
Yeah. Patience is a good one. I think in life, patience is a
True.
really
Yeah.
important one. And I think you can get yourself into trouble with impatience.
Mm,
And I don't know that it's the most important one, because it's also important to have a sense of urgency.
yeah.
And like, I got to get this done.
Yeah.
And so you don't want to have so much patience that you never get the code written, because you're like,
Yeah.
oh, we'll get there. But also you can move so fast that you put in horrible hacks instead of taking the time to write it the right way.
Mhm.
Or the communication part, you didn't wait for someone else to finish something that they should be doing. So I can see the patience one, but I would say on that list, like by far the biggest one is the communication issue.
Yeah.
That's huge.
Yes, that was one I agreed with too. And before we close off, I just want to throw a question at you. If let's say you had a mentee who was a young software developer, there's a lot of young software developers out there. People know this field makes money now. So a young mentee come into this field, right? And just like Tony, they're seeing a new field in this, or let me phrase it better. I kind of want to say something like, if they're like Tony, they started with something they really like, maybe physics or chemistry, as he said, but now wants to push into robotics or something, right? What are like the three advice, or maybe two or one? What is the advice that you would give this person? Um, they probably have some problems with patients, or they're probably proud of the work they do. They've never been told that they're wrong. They've never been challenged. They've been the best in their high school, middle
It's good.
schools,
Yeah.
college. They've been the best. They've probably a little bit looked down on people because you're so good, or maybe disregarded people because you're
Yeah.
so good, and they're not good at working with others. What would be your advice?
So actually years ago, I had a young woman cold call me and say almost this, they went to become a civil engineer.
Mm-hmm.
And they were like, I was at a technical school. How did I not know software was a thing? And they
Yeah.
started writing some software, realized they loved it. They said, how can I get into the industry? And so first of all, I think on that side, I want to just hand you confidence and have that confidence that you can do it. The number of things I see where top tier developers do that less experienced or developers who aren't as sharp don't do is that they're afraid to go after the problem. They're like, that's probably not a problem you can solve. And the top tier developers are like, then I guess I'll be the first one to solve it.
Oh, wow.
And they'll try anyway. So that confidence, yeah, I don't know how to just give it to you, but I want to just give you that confidence. Go, just try stuff. Like, what's the worst that could happen if you don't succeed, if you can't create it? Like, just try. You already failed if you didn't try. You might as well fail trying instead of fail sitting in a corner and knowing you're right. So try. Just give it a shot. There's nothing to lose. And that also will make you a better developer. If you're just getting into the field or whatever, that will make you a better developer. The other thing that I would add to soft skills that I think is crucial that they didn't have on their list over there is humility, which sounds like a funny contrast to the self-confidence to go try things. But you need to have the self-confidence to just go try stuff. And instead of going, probably isn't possible to do that, freaking try. And then when someone else says to you, hey, have you looked at this way to do it? Well, no, I have a way. That lack of humility is going to hurt you. I know immediately you don't know everything you need to know about software development because you're blocking great ideas.
Yeah.
And that humility to go, you know what, there's people around me who have great ideas, who can help me grow. That humility is a huge soft skill, and one that we definitely check for in interviews as best we can. That's so important. And have that humility to make to grow from others and to learn from a mentor, learn from somebody who knows less than you. If you can learn from people who know less than you, there's no stopping your career or your learning trajectory.
That's really great. I like hearing that. I think that can go for any high achieving field, like anybody who's a high achiever. Like if you're really good at your craft, you probably need to practice a little bit humility because people might come in one day and see a problem that you never saw.
Yeah.
So definitely an advice I'll take for myself. Ooh,
Yeah,
okay.
that's right. Okay, one thing I want to interject for you that will make fodder for all the comments is our set of priorities. This is in priority order on how we think about code reviews and what you should be thinking about code reviews. And I know we all have strong opinions about this, so I'm going to give you the things that we prioritize. So number one, architectural issues with other modules. Will the way this is developed be an issue for anyone else's features, modules, implementations? The code you wrote breaks somebody else's code. That's the number one thing I want to catch. Number two, bugs. Number two on our priority list is, are there bugs in the code? And this is one of those things where people will say, yeah, that's not possible to check for in a code review. I promise you it is, but it's way easier to assume that it's not possible. And it helps the final code if you can find bugs in it. Third, modularity, code reusability, good coding practice, and consistency with surrounding code. Those kinds of stylistic things are third on our list. Fourth is style conformance. Are you complying with the coding standards at Geisel or the Python coding standards or whatever, Linux kernel coding standards, whatever applies to that? Fifth, anything else of importance that pops out at you? And number six, after anything else of importance that jumps out at you, grammar and punctuation. In fact, if we ever do a live code review with a bunch of people in a room looking at it, we have a rule. If your first two comments on the code revolve around comments or grammar and punctuation, you are invited not to speak again for the rest of the code review. Because we want you looking at the code, not easy. It's easy to go, hey, that doesn't have a period in the comment. We don't care. We want to make the code better. This is not a grammar test. And so the absolute last thing you should be looking at is grammar and comments. So those are the Geisel software 6 priorities when doing code reviews. Hey, thanks so much for joining us, Harriet. This has been great. I like this episode. This is a lot of fun.
Me too.
And don't forget, click the like button right here, or not here. It's here. Do you have it? Subscribe, all that stuff. Check out Geisel.software if you want to see open positions. We're hiring for it here at Geisel, and we hope this brought you some value today. Thanks, everybody.